Hello guys, good morning. Is everything all right? Audio, video, everything? Just let me know, then we can start today's session. Is everything all right? Audio, video, everything? I hope everything is all right. If there is an issue in the audio, you can let me know. Today, we'll be discussing the third part of angular momentum, and hopefully this is the last part of angular momentum, and it will be completed by this lecture. Everything all right? Okay. So what I was talking about on the last class, we are talking about spin algebra and Pauli spin matrices. So Pauli spin matrices we have already introduced. Let us now talk about few things which was left. So you see, the spin angular momentum S was written as Sx I cap plus Sy j cap plus Sz k cap. Okay, good morning Murli. Now we defined this Sx, Sy, Sz in terms of the Pauli spin matrices, right? Now you see, we can express these components of S with the help of spin operator. So you can give the heading representation of spin operator. So we have Sx, which is h cut by 2 sigma x, we told you. So this is h cut by 2, sigma x is equals to how much? 0 1 1 0. Then we have Sy, h cut by 2 sigma y, h cut by 2 sigma y, 0 minus I plus I 0. You need to remember these three Pauli spin matrices. Their forms are very important. 1 0 0 minus 1. So these are the three components of the spin angular spin angular momentum. Now if I talk about S square is what? S square is equals to how much will be the value of S square? It is Sx square plus Sy square plus Sz square, right? And Sx is equals to h cut by 2 sigma x. So it is h cut by 2 whole square sigma x square sigma y square sigma z square. So what it is becoming? H cut square by 4, and this is what? Sigma x square plus sigma y square plus sigma z square. So all of them are identity. So 3 times identity. So it means 3 by 4 h cut square, identity means 1 0 0. Can I write it? In a similar fashion, we can write Sz. Sz is equals to h cut by sigma z. So S square and Sz, these two are important. We have already written Sz, so I am not writing it again. So this, the way L square and Lz was important, here the important things are Sz and S square. Now if I write in terms of the bracket notation, let's say how this S square and Sz behaves. If I talk about the behavior of S square, let's say for angular momentum, orbital angular momentum, we took the eigenkette to be denoted by Jm or Lm, right? Lml or Jmj, you can say. For this, the spin, what is the value of spin? If you talk about electron, spin is half. So S square. S square and Sz will also have a common eigenstate. So S square, let's say this half. What does the first term represent? It represents S, spin quantum number, and half magnetic spin quantum number. So it is like this term represents small s, this term ms, we can say. So S square, how it behaves, 3 by 4 h cut square. So 3 by 4 h cut square. Half. Actually, this is how this is coming, s into s plus 1 h cut square. In this way it is coming, 3 by 4. You see, s square, the way L square was behaving, s square will also behave, s into s plus 1 h cut square. So half into half plus 1 h cut square. So that is 3 by 4 h cut square. So that is why we are getting 3 by 4. Okay. And if you see, for the value of s, for a single value of s, there will be two values of ms. If s is half, ms will be plus minus half. So if you apply s square, half minus half, this will again become 3 by 4 h cut square, half minus half, because we know the value of ms lies between pluses and minuses, right? In a similar fashion, if you write the relation for Sz, so Sz half. Let me know what will be the value of it. The way s square is behaving, Sz will behave like this, ms h cut, right? So it is half h cut actually. If I take plus, or you can take minus, so plus minus half h cut will be coming. So Sz half, this will be h cut by 2, half, and when we apply Sz to half minus half, this will give you minus h cut by 2, half minus half. Is it clear? On this regard, you can also keep a note of these two operators, s plus and s minus. S plus, how do you get s plus? S plus we get by doing sx plus isy, and this will give you h cut 0 1 0 0. On the other hand, s minus, sx minus isy, this will give you h cut 0 0 1 0. So I think this is pretty much theory about the spin. Let's go for some problem if it is done. Let's try to solve this problem. LJ are same and different. It is basically same, just two symbols. Sometimes they are, look, L represents mainly when you have a single thing. Okay, J is generally used to denote the summation of two things. But in quantum mechanics, both are equally used. You can treat them equally. The Hamiltonian of an electron in a constant magnetic field B is given by H equals to mu into sigma dot B. Mu is a positive constant, sigma denotes the Pauli spin. Matrices. Let omega is equals to mu B by H cut and I be the 2 by 2 unit matrix. Then the operator e to the power IHT by H cut simplifies to. Can you solve this problem? Look, try to notice this problem. Very good problem actually. What is the given operator? Given operator e to the power I H T upon H cut. Let's do step by step, then it will become very easy for you. E to the power I. What is H? H value is given here. Mu into sigma dot B. So let's put up this value. Okay. Mu times sigma dot B times T by H cut. Now you see, omega is given in terms of mu B by H cut. Mu B by H cut, but it is given in the vector form B. Now you know, we can represent any vector as its magnitude, okay, as its magnitude, and a unit vector along the direction. Okay, you can write it. You can also write it, let's say, if I am not giving any vector sign, it means it represents the magnitude of that vector along with the unit vector along the direction of the vector. You can write n cap also. So we are doing that same thing here. Vector B, we are writing B times B cap. Okay. So this will become e to the power I mu B T by H cut. What we have done? We have just taken the magnitude of B, vector B. So what remains? Sigma dot B cap, right? Because vector B is B times B cap. I hope this is clear to you. Now we have got mu B by H cut is omega. So let's put that value. So this becomes e to the power I omega T times sigma dot B cap. No issue till now. Now there is an identity you should remember. To solve this problem, we need to know this identity. What is that identity? The identity is e to the power I theta sigma dot n cap is equals to I cos theta plus I times sigma dot n cap sin theta. What is n cap? N cap is a unit vector. So using this identity, what we get? We get e to the power I H T by H cut is equals to e to the power I omega T sigma dot b cap. So as you can see, theta is replaced by omega t. So I cos theta means I cos omega t plus I times sigma dot n cap. N cap is b cap here. Sigma dot b cap sin theta means sin omega t. So this is nothing but I cos omega t plus I times sigma. If I look in the option, it is given in the vector b. So vector b, if you want to get from b cap, you need to multiply this magnitude of b. So if you multiply the magnitude of b, this becomes vector b. So we have multiplied the magnitude on the numerator, so we have to compensate it by multiplying magnitude b in the denominator, and you get it like this. Which option is it matching with? It is matching with option B. Look, so if you do the solution in a very systematic way, then things will be pretty much done. And guys, test series for CSIR-NET 2025 June has been launched. You can join that test series and you can start practicing problems, okay? And we'll start the Sunday test from this week, hopefully. So you have to do a lot of practice, guys, to solve, to get good rank in your examination. Without practice, it is not possible. Any question from this? Or let me know if it is clear. Harry, Karthik, Murli, things are clear. Let's move on to the next question. If sigma I represents Pauli spin operators corresponding to spin half particle and I cap is unit operator, then exponential I sigma y pi by 6 can be written as. Here also we will be utilizing that identity. The first identity, which we have already told you, this one, e to the power I theta sigma dot n. This identity will be useful here. E to the power I theta sigma dot n is equals to I cos theta plus I times sigma dot n cap sin theta. Secondly, if you calculate, it may not be useful, but for your information I am giving you, if you calculate the determinant of I theta sigma dot n cap, you get theta square. Tell me, I think this can be done in 2 lines. This question can be solved in 2 lines. E to the power I sigma y pi by 6. Can you do this? sigma y, look, if you want to calculate, let's say ay, this is the yth component of a. What do? You take the dot product with the unit vector along y axis, right? Then you get ay. In a similar fashion, if you want to calculate sigma y, what you have to do? You have to take the dot product with y axis, unit vector of y. Okay. So tell me, what is the answer? I would like you to solve this question, because this is easy. You can do it. Giving you some time. Just tell me the answer. Just put it into the formula. It will come. Is it not getting solved? Or you are getting so dependent on me? Once I will solve, then only you will be able to solve. Huh? This is not a good habit. At least you should give it a try. You can express it in this way to follow this thing. I, okay, pi by 6 to like sigma dot y cap. So this is I cos theta. Theta is equals to pi by 6 here, plus I times sigma dot n cap, that is sigma y sin pi by 6. So this is cos pi by 6, cos 30 root 3 by 2i plus sin 30 is half I into sigma y by 2. So this is matching with option B. Okay. Karthik, Murli, here you got B. Okay. Let's move on to the next question. The component along any arbitrary direction n cap with direction cosines nx, ny, nz of a spin half particle is measured. The result is, whenever this kind of thing is will be given in the question, that this is measured. So what you have to do, you have to find out the relevant matrix and you have to find out the eigenvalues. The eigenvalues gives the measurement. So the component along any arbitrary direction n cap with direction cosine this of the spin of a spin half particle. So what we have to find out? Of spin along an arbitrary direction. So this is what it is. So it will give you a matrix, right? The matrix will have its eigenvalue. So that is the measurement. Eigenvalues are the measurement. Spin half or negative spin half. It is spin half. Okay, spin is always half, na, for the particle. Negative will come only when it is ms. Ms may be plus half or minus half, but s is always half. Spin is half. This magnetic spin quantum number, it may be plus half or minus. Okay. So don't get confused with this negative sign. Spin is half. Like you can imagine a picture like this. Direction cosines nx, ny, nz. Let's say this is nx, this is ny, this is nz, and let's, for the sake of argument, we are considering that S is this. So you have to find out what is the component of this S along any arbitrary direction. Let's say n cap. This is S. So what is the component of S along any arbitrary direction? Let's say n cap. So obviously you have to find out S dot n cap. N cap you can imagine like nx I cap plus ny j cap plus nz k cap, right? When I am talking about unit vector, so writing this and writing this, they do not make any difference, okay? Because you see, if n is a unit vector, its magnitude is n, direction is n cap. Magnitude n is unity because it is unit vector. So n and n cap is similar, means same, okay? So try to follow what I am doing here in this problem. You have to find out the component along any arbitrary direction n cap. So it is S dot n cap. The component of spin along any arbitrary direction n cap is given by S dot n cap, and that is equals to S dot n. So n we can write, it has direction cosines nx, ny, nz. So you can write nx I cap, ny j cap plus nz k cap. Now n is a unit vector. Magnitude of n equals to 1. So we can write nx square plus ny square plus nz square. This is equals to 1. Okay, and S is equals to sx I cap plus sy j cap plus sz k cap. If it is so, then what will be the value of S dot n cap? Therefore, the value of S dot n cap, that is S dot n, will become sx nx plus sy ny plus sz nz, right? Now you know the value of sx, that is h cut by 2. If I take common h cut by 2, this is sigma x nx plus sigma y ny sigma z nz. Now you know the value of sigma x, sigma y, sigma z, nx, ny, nz, they are constant, right? So h cut by 2. What is the value of sigma x? Sigma x is 0 1 1 0, okay, 0 1 1 0. So 0 nx 0, sigma y is 0 minus I, so minus I and y plus I 0, and it is 1 0 0 minus 1 1 0 0 minus 1. So we have just multiplied the constants. Now multiply everything, 0 plus 0 plus nz, so nz and h cut by 2. So nz h cut by 2, this will be the first term. Next term nx minus I n y, and this h cut by 2 is there. So nx minus I n y. This one h cut by 2 nx plus I n y, and this one minus nz h cut by 2. This third bracket is used to denote the matrix, so we will denote it by this symbol. So this is the matrix we got. Now what is the result? To find the result, what we have to do? It has been measured, so result is the measurement, means the eigenvalues. So you have to find out the eigenvalues of this matrix. So let lambda be the eigenvalue of this matrix. So we can write nz h cut by 2 minus lambda minus nz h cut by 2 minus lambda, and the other terms remains as it is, nx minus I n y, here it is nx plus I n y. This characteristic equation equals to 0. So let's simplify it a little bit. So this minus sign we are taking outside. So minus, you see nz h bar by 2 minus lambda and nz h bar by 2 plus lambda minus h cut square by 4 nx square plus ny square, right? This is equals to 0, and this is minus a minus b, a plus b. So nz square h cut to square to the power 4 minus lambda square minus h cut square by 4 nx square plus ny square equals to 0. Now if I just keep the lambda square term aside, so minus minus plus, and this minus term we are taking to the other side, so h cut to the power h cut square by 4, if I take common, what you are left with, nx square plus ny square plus nz square, and this is 1. So lambda is equals to plus minus h cut by 2. Why? Because nx square plus ny square plus nz square equals to 1, and that's precisely matching with option D. Was it difficult? You just tell me, was it difficult? If we just proceed in a systematic way, answer will come automatically. When you convert n cap into n vector, why not divide by magnitude of n? Look, unit vector is itself a vector, right? N cap is a unit vector, so it has a magnitude of unity. It means if I take this is a vector magnitude, it will give you 1. Now we can represent this n. Okay, n is this. So how do we write its magnitude and its direction? No, magnitude is 1 and direction is n cap. So this is nothing but n cap, na? What's the confusion? So either I am writing s dot n cap or I am writing s dot vector n. Both are same because magnitude is 1. If you divide by 1, multiply by 1, doesn't matter. Do this problem now. In a basis in which the z component Sz of the spin is diagonal and electron is in the spin state psi. The probability that a measurement of Sz will yield the values plus h cut by 2 and minus h cut by 2 are respectively. Look, this problem is very special. Many times this question came in BRC and other exams. This type of problems came in GATE also. In a basis in which z component Sz of a spin is diagonal, an electron is in a spin state of psi. So if I talk about the Sz, z component of a spin, the value of Hz is h cut by 2 sigma z, that is 1 0 0 minus 1. Okay, so you can see diagonal, it's a diagonal. So this Sz will give you the eigenvalues. What will be the eigenvalues? The eigenvalues will be h cut by 2 and minus h cut by 2. These are the eigenvalues. Now the corresponding eigenvectors for this Sz will be, let's say for h cut by 2 it is phi 1, that is 1 0, and for minus h cut by 2 it is phi 2 0 1. Okay. Is it clear till now? Next, what we have to do, in the basis of this, an electron is in the spin state psi. So what is the probability of a measurement to yield these values h cut by 2 and minus h cut by 2? So h cut by 2 corresponding to phi 1 minus h cut by 2 is corresponding to phi 2. Now the given state, let us say that is vector ket psi, let us say this is equals to 1 plus I by root 6 and root 2 by 3. If we do not write in ket, then that is also okay. These are standard values for Hz. No, it is the value of Hz, right? Now if you solve this eigenvalue equation, you will get h cut by 2 and minus h cut by 2, and the corresponding eigenvector you will get 1 0 0 1. Okay, you can calculate. So you see this psi, ket psi, if I am just, let's say, writing in terms of ket, so this should be written like this: linear combination of, let's say, C1 phi 1 plus C2 phi 2. We have to express it in this way. Okay, so 1 0 should be there and 0 1 should be there. So how will you choose? Let's say if I take 1 plus I by root 6 common, then what will be this value? Psi is equals to 1 plus I upon root 6, let's say, times 1 0 plus square root of 2 by 3 0 1. Can I write it in this way? So this, if you add them, this matrix will come back. So then what is the necessity of writing it in this way? Because now we can write it in terms of this ket notation as 1 plus I by root 6. This is nothing but phi 1 and this is nothing but phi 2. Now you know from the postulates, you know this, the probabilities that the measurement of Hz will yield the value h cut by 2. So what is the probability of measuring the value h cut by 2? Means the probability being in the state phi 1, and you know the coefficient square gives you the probability, right? Therefore the probability of yielding the value plus h cut by 2 is, so when it is talking about plus h by 2, so you have to multiply, take the square of this coefficient of phi 1. So it is actually C1 mod square 1 plus I by root 6 mod square. So 1 plus I, psi star psi actually, so 1 plus I 1 minus I divided by, this is 6. So this is 2 by 6, that is 1 by 3. In a similar fashion, we can calculate the probability of yielding the value, let's say minus h cut by 2. It is mod C2 square, so square root of 2 by 3 mod square, so that is 2 by 3. And you see the total probability will be 1, there is, because there is only two possibilities. It may be either up or down. So 1 by 3 plus 2 by 3, that is 1. So this is a cross verification. Option is matching with option D. 1 by 3, 2 by 3. Look, in all the options, the sum is given to be 1, half, 2 by 3, 1 by 3, 1 by 4, 3 by 4, 1 by 3, 2 by 3. Is it clear? Murli, Harry? Will you be able to solve if I give you a similar problem? Look, this came in June 2023 and December 2023, you see, similar, very similar problem. Just they change the value. Do it. Acha, this will be H cut, na? I think this should not take more than 30 seconds. Quick, what is the answer? D or B? Look, so again SZ, again H cut by 2 corresponding to 1 0 minus H cut by 2 corresponding to 0 1. Okay, so chi is equals to 1 upon root 11 1 plus I by 3. Okay, it is 1 plus I by 3 ni. So we can just write it in this way, 1 by root 11, okay, 1 plus I by root 11 1 0 plus 3 by root 11 0 1. So it is now in this form, 1 plus I by root 11 get chi 1 plus I by root 11 by 1 3 by root 11 by 2, isn't it? So probability of getting plus H cut by 2 is equals to 1 plus I by root 11 mod square. This is 1 plus I 1 minus I by 11 2 by 11. Probability of getting minus H bar by 2, it is 3 by root 11 mod square 9 by 11. So this is matching with option B. Okay. So this is a simple problem, but this problem is very repetitive. You can see in NET exam itself it has been repeated. In GATE exam also it came. In BRC exam also it came. This problem came. This type of problem actually. Sometimes BRC give you the same kind of values. Okay, let's do this problem. Let sigma x, sigma y, sigma z be the Pauli spin matrices and x prime sigma x plus y prime sigma y plus z prime sigma z equals to this. Then coordinates are related. So look, this problem is looking very difficult problem, but it is actually very easy. It is just lengthy, but it is easy. It is just you need to represent the given equation in matrix form. Then the solution will be done. What I want to mean, look at these options. X prime sigma x plus y prime sigma y plus z prime sigma z. So, and on the other hand side, x sigma x, y sigma y plus z sigma z. So, let us calculate x sigma x plus y sigma y plus z sigma z. Then we will get pretty much idea about many things. X sigma x plus y sigma y plus z sigma z. What is the value of this thing? You know the value of sigma x, that is 0 1 1 0. So 0 1 1 0, x is multiplied, y sigma y 0 minus I plus I 0. You have to remember, as I told you, the Pauli spin matrices, you need to remember this is 1 0 0 minus 1, 1 0 0 minus 1. So if you add it, what do you get? 0 0 z x minus I y x plus I y 0 0 minus z. So if this is the value of x sigma x plus y sigma y plus z sigma z, on the left hand side you can see we have x prime sigma x plus y prime sigma y plus z prime sigma z. So what will be the value of x prime sigma x plus y prime sigma y plus z prime sigma z? It is just we need to replace the x y z by their primes. It will become z prime x prime minus I y prime, x prime plus I y prime and minus z prime. Okay, no issue in this. Now what else we have? We have tackled this portion and this portion. Now we have exponential I theta sigma z by 2. So let us calculate exponential I theta sigma z by 2. So you see sigma z, what is the value of sigma z? If you don't remember the values, sigma x is equals to 0 1 1 0, sigma y 0 minus I plus I 0, sigma z 1 0 0 minus 1. So you have to remember this at any cost. Sigma z means 1 0 0 minus I. You know, if you have exponential like this, they will go along with these terms. So this will become 1 is there, e to the power I theta by 2 is multiplied with sigma z. So each component will be multiplied by e to the power I theta by 2. So e to the power I theta by 2, this will be 0, 0 into e to the power I theta by 2, 0 into e to the power I theta by 2, and here it is e to the power minus I theta by 2. It's about rotation, it's like transformation. Okay, it's taking unprimed to prime transformation. Understood this? I theta by 2 sigma z, it was 1 e to the power I theta by 2, then 0, okay, 0 e to the power minus I theta by 2. So in a similar manner, exponential minus I theta sigma z by 2, what will be this value? This will become e to the power minus I theta by 2 0 0 e to the power plus I theta by 2. So this property we are using from the functional matrix, right? We have done in mathematical physics, functional matrix. Now look at this. We have found this one, we have also found this one. Now we just need to write this equation in the matrix form, and then you will get this one. So let us try to write and simplify. On the left hand side we have x prime sigma x, y prime sigma y plus z prime sigma z. So we have z prime, because this value is z prime, x prime minus I y prime, x prime plus I y prime minus z prime. This is equals to e to the power, was it plus or minus, e to the power plus I theta sigma z by 2. E to the power plus I theta sigma z by 2 means this one, e to the power I theta by 2, 0, 0, e to the power minus I theta by 2. Then this thing, z x minus I y, x plus I y minus z, and it is our minus I theta sigma z by 2, e to the power minus I theta by 2, 0, 0, e to the power plus I theta by 2. Okay. Now just multiply these three matrices. Let's keep these matrices aside. E to the power I theta by 2, 0, 0, e to the power minus I theta by 2. Now if you multiply this, what you get? So z e to the power minus I theta by 2. Next, x minus I y e to the power I theta by 2. This is x plus I y e to the power minus I theta by 2, and this is minus z e to the power I theta by 2. Can I write it? Again you need to multiply. So e to the power I theta by 2, e to the power minus I theta by 2, that is 1. So only z remains. Next, x minus I y e to the power I theta by 2, e to the power I theta by 2 means e to the power I theta, and 0 and this is 0, 0, then e to the power minus x plus I y e to the power minus I theta by 2, I theta by 2, so it is minus I theta, and here what will be the value? You see, this one minus z actually. So we have to find out a relation between the primed and unprimed coordinate. Okay. So let's we can now equate. So if you equate, what we can write? Z prime is equals to z. The first thing we can write. Next, x prime minus I y prime is equals to x minus I y e to the power I theta. So it means x minus I y cos theta plus I sin theta. So this is x cos theta plus minus I plus I, so plus 1, so y sin theta. So we have gathered the real part. Next we will accumulate the imaginary part. So x sin theta minus y cos theta. So we can just now compare. We can now compare the both sides. Comparing both sides, x prime is equals to x cos theta plus y sin theta, and y prime is x sin theta minus y cos theta. So we can write, you see, x prime, y prime, z prime. So we have to write the matrix 3 by 3 matrix along with x, y, z. So it is only having z. Okay, let's start with x prime. X, y, z is 0. So cos theta, you see, cos theta, sin theta, no z term, so this is 0. Sin theta minus cos theta. Okay, have we done any mistake? अच्छा, एक तो मिस्टेक हुआ है. Look, you have minus I y prime, but here you have plus. So let's do another step to rectify this. Minus I, if I write, then y cos theta will come first, and this will become minus x sin theta plus y cos theta. So minus x sin theta plus y cos theta. So this is minus sin theta cos theta. There is no z term, it's 0. Here it is z. Z means 0x plus 0y and 1z. So 0, 0, 1. And this is matching with option B. So this was a very beautiful problem. Let me know if you have any question. Is there any confusion? Harry, understood? Murli, Karthik? Yes or no? Chalo, 2 more problems we have to do. This one, second last problem. Consider the operator x, ly pz minus lz pi, where li and pi denote respectively the components of the angular momentum and momentum operators. The commutator x, where x is the x component of the position operator is. Can you do this? Ax x is equals to ly pz minus lz py. So we can write it ly pz x lz py x. Next, ly x pz ly pz x lz x py lz py x. Now you see pz x, they do not they commute, right? And pyx, they are also 0. So what you are left with, Ly x pz minus Lz x py. This one you are left with. Now what is Ly? We have already done this problem. L is equals to R cross P, that is I cap, J cap, K cap, X, Y, Z, Px, Py, Pz. Look, we do not know direct commutation relation between X and Ly, X on Lz. So we have to go with this this approach. So I cap, you see, Y Pz minus Z Py, next plus Z Px minus X Pz and X Py minus Y Px. So this is nothing but Lx. This is your Ly and this is your Lz. So we have to put the value of, say, Ly x Pz, Lz x Py. Okay. So let's put up the value. Let me know if I am doing any mistake. This is equals to Ly is Z Px minus X Pz, Lz x Py minus Y Px, again this can be written as Z Px. This is just lengthy problem, not difficult problem. Okay. You do it by yourself, then you will be able to understand it in a better way. I am trying to do this solution in as many steps as possible. Now next, if you keep, let's say, Z x Pz Px, are you able to get it, guys? Most of the term will get cancelled. Look, let's cancel many terms. This term will be 0. Pxx will remain. Xx, it is 0. This is 0. Py doesn't commit with x. Yx. Okay. Remaining terms will be there. Pxx, x Px. So I h cut. So this will be minus I h cut, right? So z into minus I h cut Pz. This one minus x. Pzx is also 0, right? This one is also 0. The last term will survive. Pxx. Pxx again minus I h cut Py. Minus I h cut is taken common. Z Pz plus Y Py. Option B. B or A? It's a plus, so it is A. Look, if you have the good concept and good mathematical skill, then you can easily solve these problems. Nothing is there. It's just getting lengthy, but I think you can handle. Okay, let's move on to the last problem for today's session. Psi theta phi is written in the basis of spherical harmonics YLM as this. So here you see YLM means the term in the subscript, it is L, and the term in the superscript, it is M. Subscript L, superscript M. So for this term, what is the value of L? 1. What is the value of M? Minus 1. So there are two statements given to you. First statement is psi theta phi is an eigenstate of L square operator, and second statement is if Lz is measured on this state psi, the measurement will come out to be h cut 0 minus h cut. Third statement is also given, Lx square is equals to half time L square minus Lz square on its state side. This is true actually. So can you do this problem? So comment section is visible to, yes, comment section is visible to me. Did I miss any comment? Harry? Look, let's start with the first one, statement 1. Psi of theta phi is an eigenstate of L square operator. So first of all, what is given? Given thing, too much of silence. Okay. Psi of theta phi is equals to 1 by root 6. Okay, let's not use ket here. Y11, 1 by root 3 Y10, 1 by root 2 Y1 minus 1. Okay, so let's start with the first statement, statement 1. What does it say? Psi of theta phi is an eigenstate of L square operator. So if it is eigenstate of L square psi, we can represent it as some constant into psi. So L square will operate on psi. So 1 by root 6 L square operating on y11 plus 1 by root 3 L square operating on y10, 1 by root 2 L square operating on y1 minus 1. So you know the eigenvalues of L square operator is L into L plus 1. So 1 into 1 plus 1 h cut square. So it is 2 h cut square, right? This is 1 upon root 3, again 2 h cut square, because L equals to 1 here again, and here also L equals to 1. So you can write 2 h cut square times this whole thing, that is psi. So we can say L square is indeed an eigen vector or eigenstate of L square operator. So statement 1 is correct. Statement 1 it seems to be correct. Let's go for statement 2. What does it say? If Lz is measured on psi, the measurement will be h bar 0 minus h bar. How will you do this? You know, Lz if measured on psi, so it will be 1 by root 6 Lz y11, 1 by root 3 Lz y10, 1 by root 2 Lz y1 minus 1. So what is the measurement? You know, if Lz applying on yln, it gives you mh cut, right? So here what will be the measurements? Here it will give you 1 h cut, here 0 h cut, here minus 1 h cut. Okay. So what is the probability of getting plus h cut? Probability of getting plus h cut will be 1 by 6. Probability of getting 0 h cut is 1 by 3. Probability of getting minus 1 h cut is 1 by 2. Okay, na? Probability of getting 1 h cut is 1 by root 6 square, 1 by 6. Probability of getting 0 h cut 1 by root 3 whole square. Probability of getting minus 1 h cut is 1 by root 2 whole square. Now the third statement is itself true. We have already done it so many times. You know, Lx square plus Ly square plus Lz square is equals to L square. So now you see Lx square and Ly square, the expectation value. So this is equal, not 0, equal. So we can write them as this is equals to half times L square minus Lz square, and this is what it is given. So this statement 3 is also correct. Statement 2 is also correct. And statement 3 is also correct. So all of the statements, all the statements are correct. With this angular momentum topic is over. I think you will be able to solve any question from angular momentum now. What are asking? Operator does not change YLM function. Operator does not change YLM function. It change. It is an eigenvalue equation, na? This is actually, you will get 1 by root 6 h cut y11, 1 by root 3 0 h cut y10, 1 by root 2 minus 1 h cut y1 minus 1. Okay, Murli, any more question, guys? If not, then we can end the session here today. Thank you very much, guys, for joining the session. I hope you find the session useful and do a lot of practice. These previous 3 or 4 lectures are very crucial. Many questions come from this. You should practice it 2-3 times, otherwise you will not be able to capture this topic. You have to revise it 2-3 times, then it will come under your control. Okay, bye bye, take care. Revision is must. Okay, I am giving stress on this fact again and again. You must do revision every day, regularly. It's not change like raising and lowering operator. No, the property of raising and lowering operator are different. How it is changing? LZ will, this is an eigenvalue equation, okay? The behavior of LZ is like this. It will produce eigenvalue MH cut. Raising and lowering operator, they behave differently. If you consider a differential operator behaves differently. If you consider momentum operator behaves differently. Got it? Chalo, bye bye.